Good afternoon, one and all present here. Myself, P. Janagarathinam, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I had discussed about the finite element analysis and introduction and CST problem solving and all. Today I am specially going to solve about the steps involved in finite element analysis, as well as how we are incorporated the different steps by the different problems and all. Generally, finite element analysis is a numerical approach which is used to solve the structural, thermal and other fluid problems. And how we are analyzing that particular problems by using the ANSYS and different types of softwares are available. And generally this finite element method numerical procedure, this method involves modeling the structure using a finite number of smaller interconnected elements, which means this, considering the problem of L sections, we are applying the point load of P in the topmost section of the L sections. So this is the general problem given in our assessment. So first we have to subdividing the number of elements, which means we can divide the L section into smaller elements. This is the finite element modeling. Then next, this is the finite element problems, like either structural problems or non-structural problems, which means either linear problems. A structure problem means we can either solve the one-dimensional problems or two-dimensional problems. Like one-dimensional problems means like bar element, beam element and truss element, and the two-dimensional structural problem means CST elements, axis geometric problem and all comes under the two-dimensional problem. Okay, then next, this is the general steps involved in our finite element analysis for solving the structural problems. The first step is for select the element type and discretize the component, which means we can select the element type. While we are selecting the element type, for example, if we are selecting the bar element, mean we can generally select the link element and all. If we are selecting the beam element, means we can select the element type which is an beam element. The second step is the displacement functions. We have to select the displacement functions like u1, u2, how many elements we are having. Based on their element split up, we have to calculate the displacement functions. If third one is for define the stress strain relationship matrix. If once we have to calculate the displacement matrix, means based on their displacement value, we have to calculate the stress and how we are interconnected with the stress strain with the stress strain relationship matrix. After that, we have to calculate the element stiffness matrix. In our step 1, we are calculated the displacement function u1 and u2. From that step 4, we have to assemble equation for the finite element equation. So fourth one is for we can derive the finite element equation for the each element. If for example the whole element which will be converted into 3 elements, means we can either calculate the 3 finite element equations. We can combine these 3 into, we will get the step 5, like assemble global stiffness matrix. After that, we have to apply the boundary conditions. Like we have to apply the boundary condition, means for example bottommost L sections we have to fixed, means the displacement value of the bottommost L sections will be 0. So the sum of the displacement value is acquired in their topmost L section. Last one is for element strains and stresses. So this all the steps already I explained. Select the element type and discretize the components, and select the displacement functions, which means either the nodal values of the each element. And this is the general equation for find out the stress strain relationship matrix. Stress is directly proportional to the strain. This is the third step. And fourth step is for based on their stress, we have to calculate the strain value. And the fourth one is for derive the finite element equation for the each element. The general finite element equation for the element is F is equal to K into U, which means F is denoted as the force matrix, K which is denoted as the stiffness matrix, and DRU which means the displacement matrix. Okay, then fifth one is for assemble stiffness matrix. and sixth one is for based on their assembly equation we have to apply the boundary condition. We have to calculate the unknown displacement of both the L section and all in our seventh step. So and these are all the different types of analysis are solved, or we can do the analysis part by using the finite element analysis, which means the structural analysis like either static or dynamic analysis, which means the machine or product under the static conditions we have to call it as a static analysis. Under the running conditions we have to calculate the analysis means dynamic analysis, and linear and non-linear analysis, thermal analysis, fluid flow analysis means we can use that CFD, and the field analysis of electromagnetic field. Thank you. Based on these steps, next class we have to solve the different problems and different case studies of in our finite element analysis. Thank you for your patient listening. Thank you.